start by evaluating the derivative of a simple log function. So here we want to find the derivative of ln of square root of x squared plus 1. So guys, in order to find the derivative of this function, first of all, again, I already have these log properties written out here, and then let me also write the derivative of the general formula for the ln of x is just 1 over x, and then we know the derivative of ln of u. I don't like to think of this as a general form, but guys, I'm still writing it here because it's more like just applying the chain rule, and one should understand how the chain rule works, guys. I have already explained the chain rule in detail, and I have also given my version of using the chain rule with a quick and easy way. Okay, so it's just simply 1 over u based on the inverse function, based on the fact that the derivative of an ln of x is just the inverse function, but one has to multiply the derivative of the inner. That is the whole idea of the chain rule. So guys, based on that, one can just directly start using this idea here, or guys, to make life a little easier, what one can do is one can use the properties. And guys, that's the reason why I have all these properties here, and that's the other reason is that I want to let people know that the properties are going to be very useful and important when we are trying to evaluate the derivatives. It's going to make our life easier. So how can we use the property here? So first thing is d over dx. Guys, this guy right here. So let me not even worry about the derivative first. Let us first try to work with the log function and see if we can use some properties. Guys, this log function can be written as ln of x squared plus 1 raised to the power 1/2, because the radical is same as raised to the power 1/2. So when I see something like this, then I look at the log properties and I can see that I can use just this power property on this. Using the power property, it would just become 1/2 times ln of x squared plus 1. So just by using this power property and writing it as a product of 1/2 times this ln of x squared plus 1 is going to make my life easier when I start actually writing the derivative of this function. If I just start with this without using the property, guys, it's going to be a little complicated, or it's going to be more work for us to actually write the derivative, but with this, it's going to be easier. So now let us try to write the derivative of this function. So writing the derivative, so d over dx of this whole function 1/2 ln of x squared plus 1. Now what we can do first of all is we know what to do with the constants. When we are trying to find the derivative, we just take them outside because we don't do anything with them. So just take this 1/2 outside, and it's just d over dx of ln of x squared plus 1, right? Now let us simplify further. Guys, this 1/2 will still stay outside. To write the derivative of this, one has to again go back and use the general rule, which says that the derivative of this function is going to be the inverse function, 1 over x squared plus 1. But I cannot just stop right here, or we cannot just stop right here. We still have to multiply by the derivative of the inner. That is what the chain rule basically says here. You just have to multiply by the derivative of the inner. Well, derivative of the inner is just finding the derivative of x squared plus 1, which is just 2x, because the derivative of 1 is 0. So guys, that is it. We don't have to do anything more than that, except for, yes, we got to cross out or simplify things. Here 2 will cross out. We'll be just left with x over x squared plus 1. That is the derivative of this function. Now guys, if we don't simplify this using the properties, then again we could use the idea of the chain rule, but it would be a little more complicated. And guys, if you want, you can try it and see that it's going to be more complicated if you don't use one of the properties. And in this case, we just have to use the power property. So guys, again, please make sure that you use the properties before you start applying the rules for finding the derivatives. Okay, so this is the first example. I'm going to show you many different types. Till then, guys, keep watching these videos. I will see you next time.